Hi everyone, welcome back to your channel I Love Pharmacology, and in this session let's understand the pharmacology concept which comes under general pharmacology, that is kinetics of elimination. So let's understand first order kinetics and zero order kinetics. As you know that there is a first order and zero order. So how to remember first order? So first order, the first letter is F. So it is the fraction. So first order means you need to think about fraction, whereas zero means zero bank balance. So what is there in the bank? You keep amount. So amount will be constant. Otherwise, you can remember it as zero amount O. Zero bank balance and amount. So first order fraction is constant, whereas in zero order the amount is constant. So what about the rate of elimination? So rate of elimination in case of first order kinetic is proportional to the plasma concentration. That means that whenever there is an increase in the plasma concentration, the exact proportion of the drug will be eliminated from the body. So that means, what do you understand by fraction? So fraction means it is a proportion or it's a percentage of drug that will be eliminated over a time. So the fraction will remain constant. For example, if you take 50% of the drug will be eliminated in 1 hour, so that 50% of the drug will be eliminated in the second hour also, based on the plasma concentration present. Whereas in the zero order, the constant amount means if you take a amount of elimination to be 20 out of 100 molecules. That means the amount of elimination per hour will remain constant. That is, it will be 20 molecules will be eliminated per hour. So whereas what about the rate of elimination in case of zero order kinetics? So the rate of elimination will be constant. What about the clearance? So please remember, so since the fraction is constant, the clearance will also be constant, and also the half-life which is required to clear the drug molecules or the drug concentration from the body remains constant. So in first order kinetic, the fraction remains constant, clearance is constant, and the T half is constant. So three things you should remember: first order, fraction is constant, clearance is constant, and T half is constant. So whereas the rate of elimination is proportional to the plasma concentration. So when it comes to zero order kinetics, the amount is constant, the amount of elimination is constant, and also the rate of elimination remains constant. So what is the rate of elimination? Will remain constant. Only the 20 molecules will be eliminated per hour. So what about the clearance? So here you need to remember, with respect to zero order kinetic, the clearance is inversely proportional to the plasma concentration. As the plasma concentration increases, the clearance will decrease because there is a constant amount of drug is eliminated per hour. So it is not proportional to the plasma concentration. So that's why the clearance will decrease and plasma concentration will increase. Whereas it is not the case with the first order kinetic, because the rate of elimination is proportional to the plasma concentration. So that's why the clearance will remain constant. So what about the T off in case of zero order kinetic? So in case of zero order kinetic, T off is proportional to the plasma concentration. So what is half-life or the T half? It is the steady state at which 50% of the drug will be eliminated from the body. So as the concentration increases, even the T off with respect to the zero order kinetics will be proportional to the plasma concentration. But you should remember that whenever there is a higher concentration, what happens to the T half with respect to zero order kinetic group of drug? If the drug has got high concentration, T half will be more, whereas low concentration T off will be less. In other words, high concentration means half-life will be more and there will be less clearance of the drug, and low concentration means T off will be less and more of the drug will be cleared from the body. Is that clear? So to understand this, let us take up this example. So as you can see here, so this is the first order kinetic and zero order kinetics. Suppose let us assume that we take 100 molecules of drug. So whenever you administer 100 molecules of drug, if the drug has to follow first order kinetics, so the constant fraction of the drug has to be eliminated. So here 50% of the drug is eliminated per hour. That means 50 molecules will be eliminated. So in 1 hour, it from 100 it becomes 50. Again from 50 minutes, again 50% of the 50 molecules will be reduced or eliminated per hour. That means the 50% of 50 will be the 25, and again in the next hour 50% of the 25 will be 12.5, and again in the next hour 12.5 50% will be 6.25. So this is how the first order kinetics will follow. On the other hand, the zero order kinetics, for example, if you assume 100 molecule, so when you administer 100 molecule of a drug, so zero order means it is the bank balance, it is the amount. So there is a constant amount of drug will be eliminated. So let's take an example that 20 molecules will be eliminated. So here it is not the percentage, it is the number, it is the amount, whereas in the first order it is the fraction or the percentage. So zero order kinetics, if 20 molecules is eliminated per hour, the constant amount here is the 20 molecule. So what happens, 100 will be converted into 80 molecules after 1 hour, and again from the 80 molecules in the next 1 hour, again only the 20 out of 80 molecules will be removed. So it becomes 60, and out of 60 again in the next hour 20 molecules will be eliminated and it becomes 40, and in the next hour 20 molecules will be eliminated and becomes 20. So here the constant amount is eliminated, whereas the constant fraction or the percentage of the drug will be eliminated. So that's why in the first order the fraction remains constant, and zero order the amount remains constant. So what about the rate of elimination? So here the rate of elimination is proportional to the plasma concentration. So let's here, so here is the 100 molecule. So this is the rate of elimination 50 per hour. So out of this plasma concentration 50, so 25 per hour. So exactly the 50% of the drug will be eliminated. Out of 25, 12.5 per hour will be eliminated. 12.5 and it is 6.25 will be eliminated from 12.5 likewise. So that means the rate of elimination is proportional to the plasma concentration. So the rate of elimination is proportional to the plasma concentration everywhere. So whereas in the zero order, the rate of elimination is constant. See here, at out of 100 molecule, only 20 molecule per hour will be eliminated in each hour. So out of 80, only 20 per hour in 1 hour. In next hour also out of 60, only 20 per 20 molecule per hour will be eliminated. That means, so the rate of elimination is constant. So rate of elimination is 20 everywhere. So that's why the rate of elimination is constant. Here the rate of elimination varies because the plasma concentration varies. So that's why in the first order the rate of elimination is proportional to the plasma concentration. So next, coming to the clearance. So clearance can be defined as the rate of elimination divided by plasma concentration. So here the rate of elimination is 50 per hour and here the plasma concentration is 100. So what will be the clearance? So clearance will be half of the 100, half of the 100. So here also out of 50, 25 will be the rate of elimination, plasma concentration is 50, clearance is this half. And also in the subsequent elimination, the clearance remains constant. So everywhere you can see off, 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 off in the first order where clearance remains constant. Whereas here when it comes to zero order kinetics, you can see here, so this is the rate of elimination and this is the plasma concentration. So here, although the rate of elimination remains constant, when it comes to the clearance is inversely proportional to the plasma concentration. As the plasma concentration increases or decreases, there is an inverse relationship. That means as the plasma concentration increases, the clearance will decrease. So here you can see that clearance is inversely proportional. So whenever if you increase the dose 100, so if now you have administer 100 molecules, again in next 1 hour if you administer 100 molecules also, the elimination clearance will be 0.20 only. So that means the clearance is inversely proportional to the plasma concentration. So here you can see the clearance here. So one more concept you should remember it. At higher concentration, what happens to the clearance? At higher concentration, there is a less clearance of the drug. Whereas at the lower concentration, the elimination is more. The clearance is more. So these two concepts you need to remember. At higher concentration, the clearance is less. At lower concentration, the clearance is more. So you can compare with this. The clearance of this is more when compared to this. When the drug concentration is more, the clearance is less. When the drug concentration is less, the clearance will be more. And also, what about the T off? Whenever the higher concentration is there, it takes what? It has got more T off for elimination. So here you can see for 100, for example, here if you take the 100 molecules in the first order kinetic, to reach a 50 molecule, it is taking 1 hour. Whereas in the zero order, to the T off means, as you know, it is steady state concentration at which the 50% of the drug will be eliminated at a given time. So 100 molecules if you give, to attain a 50 molecules, how much half life is it is taking? It is taking 1 hour, and again here half an hour. Between 60 to 40 it is taking 1 hour. So when it comes to the 50 molecule, so it will be half an hour. So it is taking around 2.5 hours for a drug to get converted into 50%. So that's why the half life is increased, whereas half life is constant. Half-life is constant here. So see here, you can see 100 molecules, the half-life is constant with respect to each of this concentration. So from 100 to 50 it is taking 1 hour, from 50 to 25 it is taking 1 hour, 25 to 12.5 it is taking 1 hour, and from 12.5 to 6.25 it is taking 1 hour. Whereas from 100 to 50 it is taking 2.5 hours with respect to zero order kinetic. So for example, this is at the higher concentration. When we take a lower concentration, that is the 40, when compared to the 100 molecule, it is a lower concentration. For its to reduce into 50%, it is taking only 1 hour. So that means at the low concentration, T off will be less and clearance will be more. Whereas at the high concentration, what happens to the T half? T half will be more and clearance will be less. So this two things you need to remember. So this is the graph which shows the clearance and the plasma concentration. Whenever you plot a graph against the clearance and the plasma concentration, the first order kinetic, as you know that the clearance is constant. So it is a straight line with respect to the plasma concentration. So that's why the plasma concentration rate of elimination remains, what rate of elimination is proportional to the plasma concentration in first order. Whereas with respect to zero order, as you can see, what happens to the clearance? Clearance is inversely proportional to the plasma concentration. So as the plasma concentration increases, what happens to the clearance? Clearance will decrease. So that's why there is a drop in the curve. So next, coming to the some practical point you need to keep in mind. So almost all the drugs which you come across in your life follows the first order kinetic, because at therapeutic dose it follows the first order kinetic. Exception is the alcohol. So alcohol, what happens? It follows the zero order kinetics. So how to remember? अल्कोहल ए होता है, अल्कोहल में क्या होता है? दो जीरो होता है, एंड जीरो में दो जीरो होता है, जीरो ऑर्डर. So zero order means, so first order only, you can see first order only one O is there, whereas in the zero order 2O is there, and also in alcohol 2O is there. So it is the alcohol which follows the zero order kinetic, and alcohol means zero order means it is amount. Otherwise you can remember it as alcohol A amount. So it is the amount that remains constant with respect to the alcohol when we consider the elimination of the alcohol per hour. So that's why it follows zero order kinetic. For example, let's take if you have consumed the alcohol like beer, wine, whiskey, anything, although it is injurious to health. So for the teaching purpose, so whenever a person consumes a alcohol, the only in grams per hour will be eliminated. For example, here we have taken 10 grams. You can take any grams, that is 20 grams per hour. Per hour it takes 20 grams to get eliminated. That's why it takes longer time to get eliminated from the body. Whenever a person consumes alcohol, the alcohol will remain in the body for a longer time. So because of the zero order, because the clearance is not more, clearance will be decreased in zero order, and clearance, as you know, is inversely proportional to the plasma concentration. As the alcohol intake increases, the clearance will decrease. That's why it follows the zero order kinetics. So next, coming to the examples of zero order kinetics. So how to remember? Zero order kinetics means 0 watt per. So W stands for warfarin, A stands for alcohol, T stands for theophylline, one more T stands for tolbutamide, and P stands for phenytoin. So next, coming to the how this is the justification for why some of the drug follows the first order kinetics, and why some of the drugs follows the zero order kinetics. So let's assume that you have given a drug. It contains 100 molecules, and in the body also you assume that the body has got 1 lakh or 2 lakh enzymes in a body, total 2 lakh enzymes or 1 lakh enzymes in the body. So since you have administered 100 molecules, now the body will be able to release the 100 enzymes which will be able to metabolize the 100 molecules. So similarly, whenever you give a therapeutic dose in first order kinetics, what happens? So there is a enzymes which has been fixed in our body. So till that enzymes get saturated, so it will follow the first order kinetic. Any drug in a therapeutic dose within the limit, and if the enzymes are proportion to the drug molecules you are giving, it follows the first order kinetic. If the enzymes are exhausted and the dose is more than that of the enzymes present in the body, what happens is it follows the zero order kinetic. It follows the zero order kinetics. So here you can say that, so since the body has got maximum of 1 lakh enzymes, so whenever the drug concentration is increased, if you increase to 200 also, the body has capacity to release 200 enzymes to metabolize 50 to 50% in 1 hour, and even 400 milligram, 1000 molecule, and 1 lakh molecule, if you administer, the body will be able to release the 1 lakh molecule to metabolize the drug. So till this stage, the drug follows first order kinetic. If you increase the dose to 2 lakh, what will happen? 2 lakh, 5 lakh, 10 lakh. Now the enzyme required for metabolism of the 2 lakh molecule of a drug is not present in the body, because the body has got only the 1 lakh enzymes. So now what happens? It follows the zero order kinetics. That means the clearance is inversely proportional to the plasma concentration. So as the plasma concentration increases, the clearance will decrease. So what happens to the rate of elimination? Rate of elimination will remain constant in case of the zero order kinetics, whereas here the rate of elimination is proportional to the plasma concentration. Exactly 50% will be eliminated because the body has got that sufficient surplus enzyme for the drug molecule which you are going to administer. So first order kinetics will be followed only when there is a surplus of the enzymes in the body. Whenever the enzyme amount will decrease, whenever the enzyme number gets saturated or gets limited, then the drug will be converted into the zero order kinetic. The amount of elimination will remain constant here. So that is the example which we took. That is the, if you take 100 molecule of a drug to get metabolized, if the body has got only the 1 lakh molecule, so what is the two scenarios? So one is the first order and another is the second order. If the enzymes are sufficient, so you should remember, if the enzymes are sufficient, so what happens? It follows first order kinetics. So if the enzymes are limited or it is saturated, saturated means if the dose is more than the number of enzymes present in the body, it follows the zero order kinetics. So that is what in low dose, usually most of the majority of the drug will follow the first order kinetic. At higher dose, when the enzymes get saturated, the drug will follow the zero order kinetics. So that is how there is one more name given to the zero order kinetics. Zero order kinetics also known as saturation kinetics. And also Y means the enzymes get saturated. Enzymes will not be available for the amount of drug that you will going to administer for metabolism. And also here you can see that, for example, if the drug molecule is 5000 and enzyme present in the body is 500, what happens here? It initially it follows the zero order kinetics. So once the drug concentration reduces less than 500, so what happens is the same drug will going to follow the zero order kinetic. That means at low dose it follows the zero order kinetic, even though the therapeutic dose is high. If the therapeutic dose is high, then at higher doses it follows the zero order, and in low doses it follows the first order kinetics. This you should need to remember. So that's why the alcohol at the higher concentration follows the zero order and lower concentration it follows the first order. That's why it is called as pseudo zero order kinetics. So if you take an example of the aspirin, for example, since aspirin follows the dose dependent actions, like at lower dose it produces antiplatelet action followed by antipyretic, analgesic, and at higher doses it produces anti-inflammatory action. So let's suppose take an example that if the body has got 2000 enzymes for the metabolism of the aspirin, if the antiplatelet action is produced at 500 molecules of aspirin and 1000 for antipyretic, 1500 for analgesic, and the 3000 for anti-inflammatory. So what happens is initially at the therapeutic dose, it follows the first order kinetics. So enzyme is sufficient to metabolize this. Again, enzyme is sufficient to metabolize 1000 molecules. Again, enzyme is sufficient to metabolize the 1500 molecules of aspirin. So when only at the anti-inflammatory dose is more and enzymes are less. Here it follows zero order kinetics. So once the molecule will reduce to 200, it follows the first order kinetic. So low dose it follows the first order kinetic. At higher doses it follows the zero order kinetics. So if the MCQ comes like this, what you need to do is, for example, they may ask whether these drug follows the first order kinetics or zero order kinetics. Suppose the 1000 milligram of drug is given and 20% of the drug is eliminated in 1 hour. That means 20% of the 1000 milligram will be 200 milligram is eliminated. The remaining will be 800 milligram after 1 hour. So what will be the uh, plasma concentration after 3 hours? If they ask what is the plasma concentration after 3 hours with respect to the drug which is following first order or zero order, they are going to give after 3 hours this drug, since it follows the first order kinetic, what will be the concentration that remains in the plasma after 3 hours if the drug follows first order. So you need to remember, in 1 hour it produces 800 milligram, 2 hour it produces again the out of 800, 20% of 800 will be removed and remaining will be 640. And again from 640, 20% of the drug will be removed, and after 3 hours it will be 412. This is about the first order kinetic. So if you have to choose the answer for such kind of MCQs which follows the first order kinetics after 3 hours, here the answer will be 412. So if the drug follows zero order kinetics for the same example, so as you know that the constant amount will be eliminated. So 20% means here 200 milligram will be eliminated every hour. So after 800, 200 means 600. After second hour, it will be 600. After 3 hours, again 200 will be eliminated. That means it will be 400. So this is how you need to remember from your exam point of view. So let us just summarize. So first order, what happens is, what happens to the which remains constant? So here the constant fraction is constant. What happens to the T of? T of remains constant. Clearance remains constant. Only the plasma concentration is proportional to the rate of elimination. The rate of elimination is proportional to the plasma concentration. Whereas here, which is constant, so the constant here is the amount is constant. Amount is constant. And what happens to the rate of elimination? It remains constant. It remains constant. What happens to the T of? T of, that's what you need to understand. At high concentration, the T of will be more and clearance will be less. At low concentration, T of will be less and clearance will be more. And plasma concentration, sorry, the clearance will be inversely proportional to the plasma concentration. So this thing you need to remember. Hope this concept has been made easy for you to understand. So if you find this video useful, please do subscribe to our channel I Love Pharmacology for more updates on pharmacology. Thank you.